I want to talk about Antarctica. They are clearly protecting or preserving something that may or may not be under 3 miles of ice.
Throughout history, tales of Antarctica have permeated cultures and civilizations across the world. From ancient folklore to modern-day legends, stories abound of lost civilizations, mythical creatures, and untold riches hidden beyond the frozen barrier.
And there's undoubtedly a time, they found fossils on Antarctica, there's undoubtedly a time when Antarctica was a possibility of a lost civilization.
As whispers of these tales echo through the icy winds, explorers are drawn to the edge of the world, seeking to uncover the truths concealed within the icy depths. Join us as we dig deep into the biggest mysteries lurking beneath Antarctica's ice sheets. Nestled at the southernmost tip of our planet lies Antarctica, a land of stark beauty and unfathomable mystery. Antarctica is larger than the USA and Mexico combined, and yet, we still know next to nothing about what's hidden behind its menacing ice wall. At the heart of Antarctica's enigma lies its extreme environment. It is the coldest, driest, windiest, and highest continent on Earth. Temperatures can plummet to bone-chilling lows, reaching record lows of -89.2 degrees Celsius. In such inhospitable conditions, life struggles to survive, yet Antarctica teems with resilient organisms adapted to its harsh environment. From microscopic bacteria to majestic penguins, life finds a way to thrive against all odds in this frozen wilderness. Beneath Antarctica's icy surface lies another layer of intrigue, the vast network of subglacial lakes. These hidden bodies of water, isolated from the rest of the world for millions of years, hold secrets that could revolutionize our understanding of life on Earth and beyond. Scientists believe that these subglacial lakes may harbor unique ecosystems, home to extremophiles, organisms capable of surviving in extreme conditions. Exploring these hidden realms could provide vital clues to the origins of life and the potential for extraterrestrial life in similarly harsh environments. The exploration of Antarctica has led to numerous scientific discoveries, each unveiling a piece of the continent's enigmatic puzzle. Fossil discoveries offer glimpses into Antarctica's ancient past, when lush forests and diverse wildlife once thrived in what is now a frozen wilderness. Evidence of past climates, preserved in ice cores drilled from Antarctica's vast ice sheets, provides invaluable insights into Earth's climate history and the impacts of human activity on the planet. However, Antarctica's mysteries extend beyond the realm of science. Geopolitical tensions simmer beneath the surface of this seemingly pristine landscape. The Antarctic Treaty System, established in 1959, aims to preserve Antarctica as a natural reserve dedicated to peace and science. Yet, competing claims to territory and the potential for resource exploitation threaten to undermine this delicate balance. The continent's geopolitical significance as a reservoir of freshwater and mineral resources adds another layer of complexity to its enigmatic nature. So, what's actually lurking down near the South Pole? Well, gold-spurting volcanoes, the endless maze of underwater rivers, a weird upside-down world lurks beneath ice sheets and blood-flowing waterfalls for starters. They say that money doesn't grow on trees, although we all wish it did. However, down in the icy abyss of Antarctica, gold really does shoot out from volcanoes. As part of what is already a miraculous environment and ecosystem, the eruptions from Mount Erebus contain microscopic particles of our favorite shiny mineral, gold. Mount Erebus, the largest volcano in Antarctica, is spewing out tiny crystals of metallic gold into the air. American geologists have found particles between 0.1 and 20 micrometers across in volcanic gases and 60 micrometers across in nearby snow. Although other volcanoes are known to emit gold, Mount Erebus is the only one to emit it in metallic form, posing a puzzle for geologists. Similar to the presence of gold-spurting volcanoes, blood waterfall also caused a problem that had eluded scientists for decades. Blood falls, named for its ruddy color, is not in fact a gush of blood from some unseen wound. Located in Antarctica's McMurdo Dry Valleys, the falls pour forth from Taylor Glacier, and the liquid bubbles up from fissures in the glacier's surface. The flow was previously a mystery, as the mean temperature is minus 17 degrees Celsius and little glacial melting can be seen at the surface. But in 2017, a research team using a special ground-penetrating radar discovered that a network of fissures in the bedrock and tunnels in the ice form a buried saltwater reservoir feeding the waterfall at the glacier's snout. The salt concentration, in combination with the pressure at the glacier base, keeps the water flowing despite the low temperatures. But what caused the sudden color change remained a mystery. In most cases, the reddish color of rocks or springs is caused by weathering of iron-rich minerals like magnetite, goethite, or hematite, also known as bloodstone. Studies conducted in the 1960s claim to have found only very small traces of such minerals in water samples from the Taylor Glacier, not enough to explain the blood-red coloration. Another possible explanation involved a mass proliferation of red ice algae in the melting glacier, but even if traces of carbon were found, no algae were confirmed. Until recently, scientists finally spotted that the devilish tinge is actually a result of the sediment underneath the water mixing with the current, creating the B-grade horror set you see before you. One of the most intriguing mysteries of Antarctica's inner Earth is the presence of vast subglacial lakes hidden beneath the ice. The discovery of Lake Vostok in the 1990s, buried beneath more than 2 miles of ice, ignited scientific curiosity and speculation about what other hidden treasures lay waiting to be uncovered. Subsequent expeditions revealed the existence of numerous other subglacial lakes, each with its own unique ecosystem of microbial life adapted to the extreme conditions. These discoveries have provided valuable insights into the potential for life in extreme environments and the dynamics of Antarctica's subglacial hydrology. In addition, rumors and speculation about anomalous structures and ancient ruins buried beneath the ice have fueled intrigue and controversy in the world of Antarctic exploration. Satellite imagery and ground-penetrating radar have revealed intriguing anomalies that some researchers believe could be evidence of a lost civilization or advanced society that once inhabited the continent. While skeptics dismiss these claims as fanciful speculation, the tantalizing possibility of uncovering ancient secrets hidden beneath the ice continues to capture the imagination of adventurers and conspiracy theorists alike. In 2012, a British research team embarked on a pioneering expedition to Lake Ellsworth, a subglacial lake located deep beneath the West Antarctic ice sheet. Their goal was to drill through the ice and collect samples from the lake to study its unique ecosystem and shed light on Antarctica's geological history. However, technical challenges and harsh Antarctic conditions forced the team to abandon their efforts, leaving the mysteries of Lake Ellsworth tantalizingly unresolved. Despite the setback, the quest to unlock the secrets of Antarctica's subglacial lakes continues, driven by the promise of new discoveries and scientific breakthroughs. Antarctica's enigma has also been fueled by conspiracy theories and tales of hidden secrets lurking beneath its icy surface. Stories of secret Nazi bases, ancient civilizations, and extraterrestrial encounters have captivated the public imagination, blurring the line between fact and fiction. While these claims lack credible evidence, they underscore the allure of Antarctica as a blank canvas upon which humanity projects its hopes, fears, and fantasies.
Of a lost civilization. I was very interested in Antarctica, and I was interested.
In 2015, Graham Hancock released Magicians of the Gods, in which he proposed the idea that there had been a civilization lost at the end of the last ice age due to 3 massive floods that happened between 12,800 years ago and 11,600 years ago. Graham Hancock illustrates his theory of a comet that crossed paths with the Earth around 12,800 years ago that vanished a great part of the lost civilization.
Because it releases a huge quantity of meltwater from the North American ice cap almost instantaneously.
So the comet hits the ice
Yeah.
that is in North America.
Did a comet hit the Earth 2,800 years ago? In the book, a compelling case is made by Hancock. The journey starts in North America in the channeled scablands. All around the land you can find unusual landscapes such as huge ripples that looks to be done by large amounts of water. Pictures can be found by Googling Scablands flood. The landscape seems almost so unusual and abnormally disrupted that long periods of floods do not seem to be able to do the job. And a huge flood must have happened, likely by a comet.
I was very interested in Antarctica, and I was interested in it because of the work of a previous researcher called Charles Hapgood. Charles Hapgood wrote a number of very important books. One of them is called Maps of the Ancient Sea Kings, which precisely goes into this issue of ancient maps that don't fit our understanding of what the world was, how the world was supposed to be known at that time. And another is called The Path of the Pole. And he proposed a phenomenon that he called Earth crust displacement.
Evidence of the comet at the time of writing could be found in nano-diamond-rich layers around 3 continents, dating around 2,800 years ago. Nanodiamonds can only be made under very high pressure, such as a collision between Earth and a comet. Also, anomalies in the Greenland ice core point toward a cataclysmic event. In 2018, 3 years after the release, a huge crater has been found under the ice sheet, dating around 13,000 years ago. Around the same date Graham Hancock pointed it out. That the Earth was challenged by a cataclysmic event between 12,800 and 11,600 years ago seems to be validated. But how do we know if there actually existed an advanced civilization before this happened? To try to convince the reader, Hancock explores different ancient sites and ruins and explains the mysteries behind them. One of the key elements of Hancock's research is his utilization of flood inundation maps. These maps are created by overlaying modern topographical data with potential sea level rises to simulate the geographical changes that could have occurred during ancient times. By examining these maps, Hancock aims to identify submerged landscapes and potential sites of lost civilizations that may have been overlooked by traditional archaeology. And he found some. The first site that is being explored is Göbekli Tepe. This site lays in Turkey and is dated to be created around 1,500 years ago. Note that this is only 100 years ago than the ending of the last ice age, 11,600 years ago. The site exists of T-shaped pillars, and there is estimated that 95% of the site is still buried underneath the sand. This site alone rewrites history, as there was thought that the first temple complex has been made thousands of years later, allegedly during the first agricultural civilizations. How did this huge temple complex, consisting of 20 temples and 200 pillars, pop up out of nowhere, straight out of the Ice Age? Where did their knowledge come from? Civilizing is always thought to be a long process of improvement, but this site seems to be built out of nowhere. Another place that is explored is Gunung Padang. This site is laid out in Indonesia and is also reported to be built around 12,000 years ago. Another place is Baalbek. At the Temple of Jupiter in Baalbek, where there are found in the foundations of the temple stones of 1960 meters with a weight of 1,650 tons. There is believed that this is done by the Romans, who have never before shown the capability to lift such heavy stones, nor capable of working with such high-weighted stones. Why did the Romans even decide to build their most ambitious project in Baalbek and not in their capital, Rome? South America is also investigated by Hancock, where you can see clearly a decrease in architecture in the workings of the Incas. Of course, Hancock also goes into Egypt, the pyramids, and the Sphinx. Off the coast of India, Hancock and his team have discovered what appears to be man-made structures hidden beneath the sea. The last time this happened was during the Ice Age, long before humans should have had the ability to build much more than a clay hut. If these structures are indeed the remnants of an ancient civilization, they challenge established historical narratives and prompt a re-evaluation of the capabilities of past societies. Notably, beside Hancock's lost ancient civilization, Plato's writings about Atlantis also provide a fascinating glimpse into an alternative ancient history timeline. In his dialogues Timaeus and Critias, Plato describes Atlantis as an advanced civilization that existed over 9,000 years before his time. Critics often dismiss Atlantis as a mere allegory, but alternative researchers suggest that it could be a veiled reference to a lost civilization that predates mainstream history. In Critias, Plato recounts that the ancient Egyptians possessed records going back tens of thousands of years, both in their own history and that of Athens. How could such histories exist when civilization in any form was only supposed to have begun 8,000 years before his time? One of the most controversial aspects of the ancient history timeline is the dating of the Sphinx. Most modern scholars think the Sphinx was carved around 4,500 years ago. Robert Schoch, a geologist, has proposed that the erosion patterns on the Sphinx's body suggest a much older origin, potentially dating back to a time when the region experienced heavy rainfall, around 12,000 to 7,000 years ago. This challenges the conventional dating of the Sphinx and opens up possibilities for a more ancient civilization that thrived in the distant past, long before the Egyptians we know of. Similarly, the age of the Great Pyramids of Giza remains a subject of debate. While mainstream consensus attributes their construction to the Old Kingdom period of ancient Egypt, dating back to around 2500 BCE, the lack of definitive evidence has left room for alternative theories. One significant challenge in dating the pyramids arises from the absence of clear inscriptions or inscribed dates within the pyramids themselves. This lack of inscriptions makes it difficult to pinpoint their exact age with certainty. As a result, scholars have had to rely on indirect methods, such as linking the pyramids to known historical figures or events, to establish a rough timeline. Some researchers propose that the pyramids might be older than conventionally believed, pointing to geological and astronomical evidence. Additionally, theories about advanced civilizations predating recorded history, like Atlantis, have been linked to the pyramids, suggesting that their origins could reach back even further in time. Ancient Egyptian sources themselves suggest a history that reaches back tens of thousands of years. The Egyptian priest Manetho account of dynastic history goes back an astonishing 36,525 years, according to ancient texts. While mainstream historians often regard these numbers as symbolic rather than literal, they also acknowledge that Manetho's work is extremely accurate. He went to great lengths to ensure that the history he was presenting was as truthful as possible. Manetho's method of grouping the dynasties of Egypt is even still used today. Why suddenly jump from facts to fiction without any indication? It's a puzzle. Regardless, from Plato's accounts of Atlantis to the mysteries surrounding the Sphinx, pyramids, and the rich history of Egypt, these alternative narratives spark curiosity about the hidden chapters of our collective history. We find ourselves questioning the limits of human achievements and the existence of advanced civilizations that might have flourished thousands of years before our conventional timeline suggests. The pursuit of these alternative narratives reminds us that the story of our past is still waiting to be fully uncovered. In addition, note that there are very few natural catastrophes that could annihilate all humans in one blow. Most of them would kill many or most humans while rendering Earth uninhabitable, and that may eventually kill the survivors of the initial catastrophe. The difference between killing most humans and killing all humans might seem pretty irrelevant to many of us, who will be dead either way. Researchers into existential risks to humanity care about the difference a fair bit, though. If Earth originating intelligent life is gone forever, that's it for all the people who ever might have lived, all the things they ever might have done, and all the worlds they ever might have settled. In that respect, it's a much bigger loss than 8 billion deaths. There are lots of prospective disasters that would kill many humans, maybe even most of us. Killing all humans, though, is a taller order. We can learn how populations bounce back from near-extinction events by looking at other animals and by statistically modeling small human populations. If there are at least a couple thousand humans in a survivor community, we'll probably make it. If there are fewer, then due to genetic effects and bad luck, we probably won't. That's good news for the survival of humanity. Even disasters that killed billions of us could potentially be survivable for the species, as long as there are some areas where large survivor communities can flourish. But living on our blue little planet seems safe until you are aware of what lurks in space. The following cosmic disasters are just a few ways humanity could be severely endangered or even wiped out. 1. The Sun. Our Sun is not as peaceful a star as one might initially think. It creates strong magnetic fields that generate impressive sunspots, sometimes many times larger than Earth. It also ejects a stream of particles and radiation, the solar wind. If kept in check by Earth's magnetic field, this wind can cause beautiful northern and southern lights. But when it becomes stronger, it can also influence radio communication or cause power outages. The most powerful magnetic solar storm documented hit Earth in 1859. The incident, called the Carrington event, caused huge interference with rather small-scale electronic equipment. Such events must have happened several times in the past, too, with humans surviving. But only in recent years have we become entirely dependent on electronic equipment. The truth is, we would suffer greatly if we underestimate the dangers of a possible Carrington or even more powerful event. Even though this would not wipe out humanity instantly, it would represent an immense challenge. There would be no electricity, heating, air conditioning, GPS, or internet. Food and medicines would go bad. Where the previous cosmic dangers occur at the roll of a dice with a given probability, we know for certain that our Sun will end its life in 7.72 billion years. At this point, it will throw off its outer atmosphere to form a planetary nebula, ending up as a stellar remnant, as a white dwarf. But humanity will not experience these final stages. As the Sun becomes older, it will become cooler and larger. By the time it becomes a stellar giant, it will be big enough to engulf both Mercury and Venus. Earth might seem safe at this point, but the Sun will also create an extremely strong solar wind that will slow down the Earth. As a result, in about 7.59 billion years, our planet will spiral into the outer layers of the hugely expanded dying star and melt away forever. 2. Supernovas and gamma-ray bursts. Supernovas happen when sufficiently large stars reach the end of their life. They release an unfathomable amount of energy and will likely kill most life on any nearby planets. Gamma-ray bursts are another high-energy astronomical event. Their cause isn't as well understood, and they too release vast amounts of energy, enough to endanger nearby worlds. These risks, according to Anders Sandberg, is a researcher at Oxford's Future of Humanity Institute, could conceivably harm biospheres at astronomical distances. Unless the explosion is close enough to cause heating, the risk comes from radiation penetrating the atmosphere, a resulting UV flash, possible cosmic ray showers, and formation of nitrous oxides that deplete the ozone layer, produce acid rain, and cause multi-year cooling climate effects. The effects, if intense enough, could plausibly cause a mass extinction. Astronomers have observed these events in our galaxy, luckily too far away to do us any harm. Should this keep us up at night? While they'd be catastrophically bad if they happened, supernovas and gamma-ray bursts are extremely rare. We also mostly know which astronomical objects cause them, and we can check our immediate vicinity to see if we have any neighbors that are candidates to go supernova or release a gamma-ray burst soon. Lucky for us, there are at present no supernova or gamma-ray burst candidates in the vicinity of the Sun that will explode in the current epoch, Sandberg finds. Our understanding of high-energy astronomical events like these is still developing, but it looks likely that we're safe. Asteroids have likely caused mass extinction on Earth before. Dinosaurs and many other species likely went extinct at the end of the Cretaceous period due to an asteroid impact that rapidly changed the climate worldwide. So could that happen to us? And would it kill us all if it did? Researchers have modeled the effects on Earth of impacts from different objects. While there are some small effects from an object's velocity and from the impact site, by far the most important factor in the damage done by an impact is the mass of the object. One study found that less than 1% of the human population would be killed by an impact from an object with a 1-mile diameter, while 100% of the human population would be killed by the indirect effects of an impact from an object 6 miles across. But Sandberg writes that these numbers are at best an educated guess. Since impacts we can observe are fairly rare, our models of their effects are incomplete. NASA is responsible for mapping near-Earth objects, NEOs, that are larger than 1 kilometer across. It has mapped more than 90% of them, which means we know their trajectories and can be confident that they aren't on their way to impact Earth. The handful of NEOs that are larger than 10 kilometers across, that is big enough to kill us all if they struck Earth, are all in safe, stable orbits. There's another category of objects to worry about, though. Long periodic comets that swing through our solar system so infrequently that astronomers haven't mapped them yet. To guess how likely that is, we have only rough estimates from looking at the comets we've observed. Sandberg concludes tentatively that the danger may be on the order of 1 2+ kilometer impactor per 5 to 10 million years. That isn't very often. Given how disastrous an asteroid or comet impact would be if it happened, though, and given that we might well be able to prevent it if we saw it coming far enough in advance, there's a strong argument that it's worth some effort and funding to improve our tracking of NEOs and our understanding of the situation. Sandberg notes that traditional statistical life valuations suggest that a $1632 billion annual investment in asteroid defense would be cost-effective. Yet U.S. government spending on asteroid detection, with no mitigation, is around $4 million per year. Impacts might be unlikely to kill us, but it'd still probably be sensible to invest further in making us more confident in that. Of course, there are other risks that are much greater than the risks posed by asteroids, so if someone had an additional $1 billion to spend annually, it wouldn't make sense to focus it on asteroids. But if we funded research into all hazards to our future, in proportion to their plausibility, the existence of promising avenues for additional research, and the good we could do by mitigating them, we'd spend significantly more resources on asteroid detection than we currently do. 3. A supervolcano. Humanity almost went extinct once before. It can be estimated from genetic analysis that the population once dipped to exceptionally low levels. Researchers think this might have been prompted by the supervolcanic eruption of Toba 70,000 to 75,000 years ago, though this is only one of many competing theories. Whether or not a supervolcano has driven humans to the brink of extinction before, such massive volcanic eruptions, which release toxic gases and cool the planet by filling the upper atmosphere with sunlight-deflecting compounds, are suspected to have triggered several other mass extinctions in the fossil record. Such events are rare, the paper concludes, with the geologic record suggesting return times of 10 to 100 million years. But would that kill humans today? That's less clear. Massive changes to our climate, anthropogenic ones like we're facing today, as well as ones caused by a supervolcano, would certainly kill many people. but humans today are spread more widely across the world than we were at the time of the near extinction. We can adapt to a wider range of climates. There are people working to make our food system resilient to shocks from a supervolcano, impact, or nuclear winter. So in some respects, modernity has made us less vulnerable to shocks to our food supply or climate. In other respects, though, it's made us more vulnerable. Many of our food, communications, and energy systems are now global, which means that shocks to the system will affect the whole world. Sandberg argues that many human systems such as food, energy, finance, and communications are global, densely interconnected systems where failures can cascade rapidly, which means that the probability of global failures also has increased compared to more local, modular, and redundant systems. Overall, it's hard to say if we're safer from extinction due to a supervolcano than we used to be. More preparation to maintain the food supply in a catastrophe might make us significantly safer. 4. Moving stars. Meanwhile, a wandering star on its path through the Milky Way might come so close to our Sun that it would interact with the rocky Oort cloud at the edge of the solar system, which is the source of our comets. This might lead to an increased chance of a huge comet hurtling to Earth. Another roll of the dice. The Sun itself follows a path through the Milky Way that takes us through more or less dense patches of interstellar gas. Currently, we are within a less dense bubble created by a supernova. The Sun's wind and solar magnetic field help create a bubble-like region surrounding our solar system, the heliosphere, which shields us from interacting with the interstellar medium. When we leave this region in 20,000 to 50,000 years, depending on current observations and models, our heliosphere could be less effective, exposing Earth. We would possibly encounter increased climate change, making life more challenging for humanity, if not impossible. After all, the end of humanity on Earth is a given. But this is not something to make us crawl under a table. It is something that we cannot change, similar to our lives having a definite start and end. This is what defines us and makes us realize that the only thing we can do is make the most of our time on Earth, especially when we know that Earth needs a careful balance to sustain humanity. All the above scenarios harbor possible destruction, but in every instance, they also offer beauty and wonder. In many cases, they produce what allowed us to be created. So rather than looking into the night sky and wondering what will kill us next, we should marvel at the depth of space, the wonders therein, and the sublime nature of the universe. Be inspired by space. It offers future and meaning. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.